Have you ever looked up at a fluffy, pristine cumulus cloud and thought, I wonder what that tastes like? It is a completely ridiculous thought, right? We see clouds as ethereal, vaporous formations essential for rain, but certainly not as a potential breakfast cereal. But what if we shifted our perspective? What if clouds were not just weather phenomena, but a viable, harvestable, and potentially nutritious resource? This is not a tale about sci-fi utopian farming. This is a deep dive into genuine scientific speculation, asking what it would actually take to turn the sky into a farm, and what the catastrophic consequences might be if we started consuming the clouds above us. Welcome to the Great Atmospheric Feast. First, we need to address the basic question, what exactly are we eating? Clouds are aerosols, meaning they are a collection of microscopic particles suspended in gas. The overwhelming majority, of course, is water in liquid or ice form. But that water needs a nucleation site to form a droplet. These sites are the cloud condensation nuclei, or CCN, and this is where our meal gets interesting. CCN include dust, sea salt, volcanic ash, pollen, soot, and perhaps most crucially, bacteria and fungal spores. If we harvest a basic cumulus cloud, we are essentially gathering extremely dilute distilled water mixed with everything the wind has recently carried up from the Earth as surface. From a purely nutritional standpoint, a cloud offers next to nothing. It is water, which is good, but it is not a caloric food source. We would have to introduce massive processing steps to fortify this sky sludge to make it worth eating. Imagine fortifying cloud water with synthesized vitamins and minerals, creating the ultimate zero-calorie hydration meal. Perhaps we could culture the airborne microbes for protein, but the primary concern is toxicity. While many airborne materials are harmless, clouds also scavenge pollutants. They absorb sulfur dioxide and nitrogen oxides, which lead to acid rain. They gather heavy metal particulates and microplastics floating up from cities. If cloud harvesting became industrialized, we would need sophisticated filtration systems to make this sky soup safe for human consumption, turning the romantic idea of eating a fresh, clean cloud into an intensely complex industrial challenge. Now, let us talk about the true mountain. We must climb the physics of collection. Clouds are vast, but they are also incredibly low density. Consider a single average-sized cumulus cloud. Its visible volume might be over 1 cubic kilometer. The problem is that its mass is spread out. While that cloud might weigh hundreds of tons in total, the density is only slightly heavier than the surrounding air. To put it simply, we would be trying to collect vast amounts of near-nothingness. How do we capture something so ethereal? Traditional concepts of harvesting involve nets or scoops, which are laughably inefficient for aerosols. We would need massive, fixed installations operating on the principle of condensation. Think of enormous, high-altitude dehumidifiers or chemical absorption towers that actively draw in vast volumes of air and force the water droplets to coalesce. The energy requirement for this large-scale operation is staggering. To collect the amount of water required to sustain a city of 10 million people for just one day, the energy cost of running these colossal atmospheric vacuum cleaners, chilling the air and processing the resulting sludge would likely dwarf the energy output of several nuclear power plants. It makes desalination look like a cheap walk in the park. Furthermore, which clouds do we target? Cirrus clouds are high and icy, difficult to reach and process. Stratus clouds are low and thin, offering little volume. We would inevitably target the large, juicy cumulus or cumulonimbus storm clouds. But actively mining these weather systems could lead to localized weather disasters, pulling the moisture out before it naturally precipitates. The moment we try to industrialize the sky, we run into the biggest problem of all: ecology. The most critical role of clouds is not just providing rain, it is reflecting sunlight. This is known as the albedo effect. Bright white clouds are highly efficient mirrors, bouncing solar energy back into space and cooling the planet. If we start removing clouds on an industrial scale, even localized removal, we fundamentally change the reflectivity of that region. Imagine a vast cloudless zone over what was once a cloudy region. That area would suddenly absorb significantly more solar radiation. This would lead to localized heating, creating heat domes, disrupting existing pressure systems, and accelerating global warming in those zones. The consequences for the global water cycle would be catastrophic. The water cycle is a delicate, continuous loop: evaporation, condensation, precipitation. By intercepting the condensation phase and diverting the water for human consumption, we are short-circuiting the system. If we harvest clouds that would have naturally moved inland to water farmlands or replenish reservoirs, we cause desertification and massive drought in the precipitation zones. Conversely, if we try to harvest storm clouds approaching a populated coast, we might mitigate a flood, but we are draining the natural reserves of inland ecosystems. We would be playing God with precipitation, guaranteeing that some parts of the world would starve for moisture so that other parts could have a strange, filtered cloud meal. The ecological trade-off is unavoidable. To produce enough cloud food for millions, we would doom millions of acres of farmland to drought. The environmental destruction caused by cloud harvesting would easily outweigh any temporary gain in novelty food source. Beyond the science and the ecology, the social and economic implications are fascinating and deeply unsettling. Who owns the sky right now? The atmosphere is generally considered a global commons, similar to the high seas. If cloud harvesting became viable, that would change overnight. We would instantly see the rise of atmospheric property rights. Imagine the cloud barons corporations or nation-states with the technology powerful enough to capture these massive low-density resources. They would control the flow of the global water cycle. This immediately turns into an intense geopolitical conflict. A nation upstream could harvest all the clouds before they drift to a neighbor downstream, weaponizing the weather. We already see skirmishes over rivers and shared aquifers. Imagine a tension amplified to the scale of the entire atmosphere. The price of cloud-based food would initially be astronomical, making it a luxury item, perhaps accessible only to the wealthy in climate-controlled megacities. The irony would be biting: the pristine, clean sky food would be enjoyed by those insulated from the resulting droughts and ecosystem collapse they caused. Meanwhile, traditional farming dependent on natural rain would become unreliable, collapsing the established food markets and exacerbating global hunger. If humanity mastered cloud harvesting, it would not solve our food crisis. It would simply shift the scarcity problem from fertile land to atmospheric resource control. Our entire food system, which relies on predictable weather patterns, would shatter. Agriculture would become dependent on the whims of the sky miners. So, let us return to that initial, whimsical thought of eating a cloud. The reality is that while the chemistry shows clouds are mostly water mixed with aerosols, the physics proves they are incredibly difficult and energy-intensive to collect, and the ecological reality confirms that tampering with the global water cycle is fundamentally unsustainable and globally destructive. Perhaps the greatest lesson here is recognizing the massive value in things precisely because they are not designed for human consumption or exploitation. Clouds are not a resource to be mined, they are a mechanism to be cherished. They are the essential, free-floating air conditioning system of our planet. If we could harvest and eat the clouds, we would gain a novelty food source that tastes of filtered water and environmental ruin, at the cost of global weather stability and predictable rainfall. Some resources are infinitely more valuable left exactly where they are, performing the vital job of keeping the lights dimmed and the rain falling naturally. Sometimes, the best food source is the one that stays safely out of reach, high up in the atmosphere, doing its essential, majestic work.